Hello, ma'am.
Good evening, sir. You can start now, sir.
Okay, ma'am. All right. Ma'am. So a synopsis on organic chemistry, the basics of organic chemistry. So I'll give you the synopsis, which will be useful for your exams. Some basic principles and techniques. So this is the first 11th standard chapter, first PUC chapter. So it will be of use. Now, everybody knows, we know that organic chemistry is a branch in chemistry, which deals with the study of carbon and its compounds. Or we can define organic chemistry as a branch in chemistry, which deals with the study of hydrocarbons. Not only hydrocarbons, derivatives of hydrocarbons also. So study of carbon and its compounds in general will be called as organic chemistry. Now, the first organic compound synthesized in the lab is ammonium thiocyanate, not ammonium thiocyanate, from ammonium thiocyanate. On heating ammonium thiocyanate, we get NH2CO, NH2. This is ammonium thiocyanate. And this is urea. The first organic compound synthesized in the laboratory is urea. And this was synthesized by F. Wohler, W-O-H-L-E-R. So the first organic compound synthesized in the laboratory is urea. Now, organic compounds like acetic acid was synthesized by Colwes, and methane was synthesized by Berthelot. So showed the organic compound was synthesized from inorganic sources. So these all were synthesized from inorganics. Ammonium thiocyanate is an inorganic compound, but urea is an organic compound. From inorganic, we can synthesize organic. These are approved by Wohler, Colwes, and Berthelot. Now, coming to carbon, since organic chemistry deals with the study of carbon, we should know that carbon is tetravalent. The valency of carbon is tetravalent, or 4. It has 4 bonds. Now, carbon, if it is only one single carbon, the hybridization of carbon is sp3. And if carbon is saturated, that means carbon has single bonds, then again the hybridization of carbon is sp3. When carbon is having a double bond, then the carbon will be sp2 hybridized. And if we have a carbon triple bond, then the carbon will be sp hybridized. We should remember this. Now, if carbon is having sp3 hybridization, percentage S character is given by the formula 1/4, 25%. 1 S orbital and total number of orbitals is 4. Therefore, 1/4 is 25. Now, the percentage S character here in sp2 hybridization is 1/3. It is 33.3%. And the percentage of S in sp hybridized orbital is percentage S character is 1/2 into 100. That will be equal to 50%. So these, you should remember the percentage of S character in sp hybridized, sp2 hybridized, as well as sp3 hybridized. Now, you also should remember, if the hybridization of carbon is sp, if the hybridization of carbon is sp, the structure of the molecule will be linear. And in the linear molecule, the bond angle is 180 degrees. And if the molecule is having sp2 hybridization, it is trigonal planar. Trigonal planar. In trigonal planar, the bond angle is 120. And if the molecule is sp3 hybridized, the shape or the geometry of the molecule is tetrahedral, and the bond angle is 109 degree, 28 minutes. You should remember this. Now, coming to the next part of the topic, that is the nomenclature, or maybe the classification. We all know that organic compounds are classified into alicyclic and cyclic. So organic compounds, basically, they are classified into two. One is alicyclic or acyclic. This acyclic is also called as aliphatic. And the other one is called as cyclic. The cyclic is generally called as a ring compound. It is not called as aromatic. It is called as what? Ring compound or a closed structure. Now, this alicyclic compounds are further classified into saturated and unsaturated. Saturated means carbon to carbon single bond. When we have carbon to carbon single bond, the hybridization is sp3. Example for a compound with carbon to carbon single bond, alkanes. The general formula of alkane is H2N, CnH2n plus. When we say unsaturated, carbon to carbon double bond or carbon to carbon triple. When we have carbon to carbon double bond, it is called as alkenes. Carbon to carbon triple bond is called as alkynes. When we have carbon to carbon double bond, the hybridization is sp2. Example, alkenes. Alkenes will have a general formula CnH2n. Now, carbon to carbon triple bond, if you have the hybridization is sp, and alkynes, and the general formula CnH2n minus 2. So you should remember this. Now, coming to cyclic compounds, these are further classified into homocyclic and heterocyclic. Homocyclic cyclic compounds, which is made up of only one type of atom, carbon atoms. Now, this is further classified into cycloalkanes and aromatic. Cycloalkanes, and aromatic compounds. And this heterocyclic are further classified into alicyclic. Heterocyclic means in a ring, it will have more than one type of carbon atom. Alicyclic, for an example, furan is an example for alicyclic. Aromatic benzene is an example. Cycloalkane, cyclopropane, cyclobutane, all those things. Now, next, coming to alicyclic, we also have aromatic compounds. So, heterocyclic compounds are also aromatic. So, example for aromatic compounds is thiophene. This is thiophene. Pyridine. These all are aromatic. Pyridine. So, cyclic compounds also can be aromatic. This is with respect to the classification of organic compounds. Now, coming to the nomenclature. Nomenclature is very important. You should know the rules of naming an organic compound and the functional group preferences, all that you should know. Please note down, go through the nomenclature. Now, nomenclature, any name and IUPAC nomenclature, International Union for Pure and Applied Chemistry, the rules are many. Now, before we go for nomenclature, we should understand what is a functional group. Functional group is an atom or group of atoms which decides or which gives the properties is called as functional group. Now, for an example, OH group is called as alcohol group. Any molecule which contains OH group will be called as alcohol. Any molecule contains COH group will be called as acid group. So the functional group is an atom or a group of atoms which gives the properties of the organic compound. For an example, O, this will be called as ether. Ether. So all these are many functional groups are there. Then the other term you need to know is homologous series. Now, what is this homologous series? Now, for an example, if we take an alkane, the general formula of alkane is CnH2n plus 2. If N is 1, we have CH4. If N is equal to 2, we have C2H6. If we have N is equal to 3, C3H8. Now, series of compound which has a general formula or a common formula and differ by successive molecules by CH2 group is called as a homologous series. The difference between this and this is CH2. The difference between this and this is also CH2. So homologous series is a family of structural organic compounds. All members contain the same functional group, but the consecutive numbers or the members differ by CH2 groups. Those are called as homologous series. Now coming to the nomenclature. This nomenclature rules to follow naming the organic compounds given by IUPAC. Now, nomenclature has three parts. One is prefix, the other one is root word, the other one is suffix. You can see the prefix is written before the root word and suffix is written after the root word. Root word indicates number of carbon atoms in the long chain. Number of carbon atoms in the long chain, parent chain. This long chain also can be called as parent chain. That is root word. Now, if I have one carbon atom, we call it as meth. If we have two carbon atoms, we call it as eth. 3 carbon atoms, we call it as prop. 4 carbon atoms as bute. 5 carbon atoms as pent. You know all this. It goes on. Hex, hept, oct, non, decane, all that. Now, coming to suffix, this suffix is of two types. One, I write it here, is of two types. One will be primary suffix. The other one will be secondary suffix. Primary suffix will give the information about whether the molecule is saturated or unsaturated, whether it's an alkane or alkene or alkyne, whether a molecule contains carbon to carbon single bond or whether the molecule contains carbon to carbon double bond or triple bond. Now, secondary suffix gives you the information about the functional group. If a compound contains functional group, then it is written as a suffix. Now, for an example, if I take a molecule like the C2H6, now we can write the structure of this molecule like this. If we write a structure of this molecule like this, I number this carbon, we have 2 carbon atoms. Root word is eth. And carbon to carbon single bond, therefore the primary suffix is ane because it is saturated. If I have a molecule like this, CH2 double bond CH2, again we have 2 carbon atoms, the root word is eth. Carbon to carbon double bond, it's unsaturated. Therefore, the name has to end with ene. It is a primary suffix. These 2 molecules do not have a functional. But if I write a molecule like this, CH3CH2OH, now this is the functional. And now I have 2 carbon, root word is eth. Carbon to carbon single bond, name has to end with N. This is a primary suffix. But we also, this is a secondary suffix, a primary suffix. And we also have a secondary suffix, a functional group. When functional group is an alcohol group, from this ethane, E is removed and written as OL, ethanol. The parent molecule becomes ethanol. The name of the molecule, IUPAC name becomes ethanol. Now, coming to prefix, again, we have 2 types of prefix, primary and secondary. Primary prefix gives you the information about substituents. Now, for an example, if I take a molecule like the CH3, CH2Cl. The number of carbon atoms is 1, 2. This is not a functional group. Chlorine is the substituent here. 2 carbon atom root word is ethane. Carbon to carbon single bond ethane. Now we have chlorine, which is the first carbon. Therefore, we write it as 1-chloroethane. So primary prefix gives you the information about substituents. Now we also have a secondary suffix. The secondary suffix gives whether the molecule is cyclic or non-cyclic. Now for an example, if you take a molecule like this, there is CH2, CH2, and here also it is CH2. By number 1, 2, 3 carbon atom, root word is prop. Carbon to carbon single bond, propane. Now I don't have any substituent here, but I have a ring here. Since I have a ring, I write it as cyclopropane. The name of the molecule is cyclopropane. So this is what you should remember. And we have different class of organic compounds. You should know the IUPAC name of different organic compounds. Now, the preferences you have to remember, carboxylic acid is given the first preference. Then we get sulfonic acid. Then we give ester. Then we give carbonyl chloride. Then we give amide, CONH2. And then we give cyanide. Then we give aldehyde. Then we give ketone carbonyl group. And then we have OH group. Then we have NH2 group. And then we have a double bond. Then we have a triple bond. So double bond is given preference compared to triple bond, you should remember. This is the order of preference. Order of preference. Order of preference. So different organic compounds are named. So you should be in a position to name the organic compound. In the papers, they've asked naming the compounds also. You cannot miss out naming the compounds. Now, this is basics of organic chemistry, what I'm telling. So you should remember all these things, what we're going to learn now. All are important. Now, coming to fundamental concepts in organic chemistry, one is fission of covalent bond. We know what is a covalent bond. Covalent bond is formed by sharing of electrons. Fission of covalent bond. Now, when we say fission means breakage, cleavage of covalent bond. The first one we have homolytic fission. This is homolytic fission, or it is called as homolysis. It is called as homolysis. Now, for an example, if we take R and X, we don't know what is this R and X. Not to worry. The bonding between R and X is a covalent bond, 2 electrons of it. If each electrons are shared equally between these groups, we get R dot and we get X dot. These kind of fissions are called as homolytic fissions. When the electrons are shared equally amongst the atoms or group of atoms will be called as homolytic fission. Whenever the molecule undergoes homolytic fission, the products formed as free radical. This is free radical. These free radicals are neutral, highly reactive. Free radicals are neutral and they are highly reactive. Now you should remember the stability of free radical is tertiary free radical is more stable than secondary, and secondary free radical is more stable than primary. This is important. Stability of free radicals. Next, coming to heterolysis or heterolytic fission. Second one is heterolysis or heterolytic fission. Heterolytic fission. This is uneven cleavage, unsymmetric cleavage. Now, for an example, if I take a molecule like the CH3Br, now bromine is more electronegative. Since bromine is more electronegative, the electron pair will shift towards bromine. Bromine gains negative charge, carbon gains positive charge. Now, both the electrons are shared by bromine. Therefore, the CH3 gains positive character and Br gains negative character. So these are our ions. When the molecule undergoes heterolytic fission, then the product formed as ions. Carbon having positive charge is called as carbocations. The stability of carbocations, you should remember. Stability of carbocations carbocations. Carbocations means carbon having positive charge. This carbocation stability is also tertiary is greater than secondary, secondary is more stable than primary, same as free radical. Free radicals. Free radicals also have stability of the same order. Now coming to carb anion. Carb anion. This carb anion can be formed when carbon is more electronegative than any other element. So carbon having negative charge. Carbon having negative charge will be called as carb anion. For an example, CH3 minus sign. Carb anion. Carbon having negative charge. Now, this carbon having negative charge, carb anion will be sp3 hybridized. Remember, carbocation will be sp2 hybridized. Carbocation will be sp2 hybridized. Likewise, free radicals also is sp2 hybridized. I didn't mention, remember, free radical is also sp2 hybridized. But carb anion is sp3 hybridized. The stability of carb anion will be primary will be greatest, more stable than secondary. Secondary will be more stable than tertiary. So stabilities of primary, secondary, carbocations I mentioned. I've thought about free radicals as well as we learned about carb anion also. The hybridization also we discussed with the stabilities. Very important. This is. Now coming to the attacking reagents. Now attacking reagents of two types. One will be a nucleophile. One will be nucleophile, NU, nucleophile. The other one will be electrophile. Now, electron-rich groups are nucleophile. Now, when I say electron-rich groups are nucleophile, generally negatively charged particles. Now, negatively charged particles like hydride ion, OH minus ion, X minus, Cn minus, nitride ion, N3 minus, NO2 minus, NH2 minus, all this. So many nucleophiles are there. All these are negatively charged nucleophiles. Likewise, we have neutral nucleophiles also. Nucleophiles can be neutral. In neutral nucleophiles, example, ammonia is a neutral nucleophile. Water is an example for neutral nucleophile. Alcohol is an example for neutral nucleophile. Ether is an example for neutral nucleophile. Lithium, aluminum hydride is an example for neutral nucleophile. So all these are electron-rich groups. They will have a tendency to donate electrons. Likewise, when we say electrophiles are electron deficient. Electron shortage. When we have electron shortage or deficient, then we call it as electrophile. These nucleophiles are generally called as Lewis base. Lewis base, electron pair donors. Electrophiles are generally called as Lewis acids. They accept electrons, therefore they're called as Lewis acid because they are electron deficient. Now, electrophiles, generally they are positively charged and also neutral. Now, positively charged electrophile, H3O plus hydronium ion, X plus, when we say X plus Cl plus chloronium ion, Br plus bromonium ion, etc. Likewise, we have NO2 plus nitronium ion, we have ammonium ion, NH4 plus. All these are positively charged electrophile. Likewise, neutral electrophiles we have boron trifluoride, aluminium trichloride, ferric chloride, FeCl3, ferric chloride, beryllium chloride. All these are examples for carbon dioxide, sulfur trioxide, carbon dioxide. All these are examples for neutral electrophiles because there will be shortage of electrons. Now, coming to the next part of the topic, electronic effect. Now, electronic effect, we should know inductive effect, electromeric effect, and we should know resonance effect. So we will not take much time here. Inductive effect happens in saturated molecules. Now, when we say inductive effect happens in saturated molecule, it is the delocalization of sigma electrons towards the highly electronegative atom. This inductive effect is of two types, minus I effect and plus I effect. Inductive effect is of two types. Now, minus I effect, when we say, if electron withdrawing group is attached. Now, for an example, if we take CH3 and Cl, Cl is an electron withdrawing. So electron move towards chlorine. Chlorine gains negative charge and carbon gains positive charge. So whenever electron withdrawing group is attached to the compound, organic compound, it will undergo negative mesomeric effect. If you have electron donating group, then for an example, if I have CH3 and if I write C2H5, it's a bulky group. This is an electron donating group. So this group will gain positive charge and this carbon gains negative charge. Then those kind of effects is called as positive inductive effect. Now you should know the strengths of carboxylic acid based on inductive effect. Strengths of carboxylic acid. Now for an example, if I take acetic acid, CH3C double bond OH, and if I take formic acid, this is simplest acid. The strength of carboxylic acid depends on the ability of the molecule to release H plus ion. Now here, the CH3 group is an electron donating group. Since it's an electron donating group, the electron pair will be pulled towards oxygen. Therefore, this OH bonds become strong. When this OH bond becomes strong, the releasing of H plus ion becomes a little difficult. But here, no electron donating group. This molecule will place H plus ion easily compared to this. Therefore, this is acetic acid and this is formic acid. Formic acid is stronger than acetic acid, or we can say the strength of carboxylic acid. Acetic acid is lesser than formic acid. This is because of plus I effect, because CH3 group is an electron donating group. Plus I effect. Now if you take a molecule like the CH3, C double bond O, C OH, sorry, this is acetic acid. And if we have CH2Cl, C double bond O, OH. This is chloroacetic acid. From CH3, one of the hydrogens replaced by chlorine. Now, since chlorine is an electron withdrawing group, the electron pair will be pulled away from the OH. Therefore, this OH becomes weak. When this OH becomes weak, this will release H plus ions easily compared to acetic acid. Therefore, acetic acid is weaker than chloroacetic acid. Or we can say chloroacetic acid is stronger than acetic acid. Now, here, electron withdrawing. So this is undergoing minus I effect. So whenever a carboxylic acid undergoes minus I effect, that is electron withdrawing group, then strength of carboxylic acid increases. Then the strength of carboxylic acid increases. Now, if we replace two hydrogens, so we'll get dichlorocarboxylic acid. Acetic acid, dichloroacetic acid. From here, two hydrogens replaced with chlorine. Since two chlorine are there, more strongly the electron will be pulled away from OH group. This bond becomes much weaker. Therefore, this will be more stronger than this. Likewise, all the three hydrogen, if we replace, we get trichloroacetic acid. Therefore, it will be this stronger. Now, coming to the other molecules, CH2Cl, C chloroacetic acid, and we have CH2F, C double bond O, fluoroacetic acid. Now, amongst these, which is strong? Fluorine is a strong electron withdrawing. All are electron withdrawing. Fluorine is also electron withdrawing, but fluorine is the strongest electron withdrawing. Therefore, this bond will be much weaker than this. This will release H plus ion easily than this. Therefore, chloroacetic acid will be less stronger than fluoroacetic acid. This is based on minus I effect. It's the strength of carboxylic acid based on minus I effect. You should remember this. Now, methods of purification. Methods of purification of organic compounds. Methods of purification of organic compounds. Many methods are there. First one will be crystallization. Now, crystallization. The principle in crystallization is solubility. Differences in solubility of organic compounds and impurities in the same solvent. So organic compound and impurity will have different solubility in the solvent. Then we can crystallize. The process is called as crystallization. Second is sublimation. Sublimation is also a method of purification. Here, sublimation is a process in which a solid is converted to vapor directly without passing through the liquid state. So sublimable compounds get separated and non-sublimable compound impurities will remain same. Now, for an example, if you take camphor and heat, this is a solid. We get vapors. Camphor get vaporized. That's a gas. Impurities will remain same. Impurities will not vaporize. That's called as non-sublimable impurities. Likewise, we have distillation. Distillation depends on boiling points. You know that distillation, fractional distillation, right? Steam distillation, differential extraction, reduced pressure distillation, chromatography, adsorption chromatography. All these terms we would have learned. So methods of purification also you should go through before going for the exam. Now coming for qualitative analysis. Qualitative analysis is also called as detection. Qualitative analysis is also called as detection. Find out what all elements is present. That's called as detection. Now, generally, organic compound will contain carbon and hydrogen. It also can have special elements like nitrogen, sulfur, halogens, like chlorine. Now, nitrogen and carbon and hydrogen is tested by copper oxide test. Copper oxide test. So copper oxide, when heated, if it contains carbon, when heated, we get carbon dioxide. Lime water will turn milky. If we are estimating for hydrogen, if you heat it, we get water droplets. These water droplets will, copper sulfate without water is white. But when it gets hydrated, we get hydrated copper sulfate, which is blue in color. So this test is a test to identify copper and carbon and hydrogen in the organic compound. Nitrogen, sulfur, chlorine, bromine, all these are tested or determined by Lysine's test or sodium fusion extract test. Kindly go through sodium fusion extract test. In the first POC, we have learned. And in case of nitrogen, there is a compound formed, Fe4, FeCN, 6 times 3. This is Persian blue color. It's a complex. Persian blue. It is ferric ferrocyanide, Persian blue. Likewise, for sulfur, the sodium fusion extract and sodium nitroprusside. Sodium nitroprusside, the formula is Na2FeCN 5 times NO. So you should know the complex name of this. What's the name of this complex? Sodium nitroprusside, all that. So sodium fusion extract, if you add sodium nitroprusside, we get a deep violet color. So these are the tests. And for chlorine and bromine, silver nitrate test, chlorine will give a white precipitate and bromine will give a pale yellow precipitate with silver nitrate. Now, quantitative analysis, we have to learn quantitative analysis. Quantitative analysis. Quantitative analysis is also called as estimation. Find out how much is present. Now, in order to understand, see, these formulas are very important. I'm going to give you the formulas. You should remember the formulas, right? So now carbon and hydrogen. Carbon, how can we estimate? So percentage of carbon is estimated by the formula. Atomic mass of carbon is 12. Carbon dioxide will be the product form. It's 44 into mass of carbon dioxide formed by mass of compound taken. Compound taken into 100. This is the formula to calculate the percentage of carbon. Now, percentage of hydrogen on the similar lines, percentage of hydrogen is given by atomic mass of a molecule is 2 hydrogen, and water is the product formed here, 18 into mass of water formed by mass of compound taken. Compound taken into 100. This will be the formula to calculate the percentage of hydrogen. Now, percentage of nitrogen, first method is Dumas method. In Dumas method, the percentage of nitrogen is calculated by the formula 1.4 into normality of acid into volume of acid divided by mass of carbon, or mass of compound taken. Compound. So percentage of nitrogen, these formulas you should remember, all are important to work out problems. So percentage of nitrogen by Geldar's method, KJELDHA, Geldar's method. So percentage of nitrogen is calculated by the formula 1.4 into molarity of acid into volume of acid into basicity of acid divided by mass of compound taken. This will be the formula to calculate the percentage of nitrogen. So percentage of halogens are calculated by Carrier's method. The formula is percentage of halogens given by the formula atomic mass of the halogen divided by 108 plus atomic mass of the halogen. Excess halogen, it can be chlorine, bromine, anything, into mass of AgX formed, silver halide formed, divided by mass of compound into 100. This is the formula to calculate percentage of halogen by Carrier's process. Now, likewise, we need to learn to find the percentage of sulfur. Percentage of sulfur, it is also by Carrier's method. So halogens are determined by Carrier's method, and sulfur is also determined by Carrier's method. So 32 is the atomic mass of sulfur, and 233 is the barium sulfate formed mass. So into molecular mass of barium sulfate. So into mass of barium sulfate formed by mass of compound taken, mass of compound taken into 100. This is the formula to calculate the percentage of sulfur and percentage of phosphorus. It is calculated, it's by ignition method. And the formula is percentage of phosphorus is given by the formula 62 by 222 into mass of magnesium pyrophosphate formed, Mg2P2O7, magnesium pyrophosphate formed divided by mass of compound taken. Compound taken. Aim to 100. This is the formula. These formulas we're supposed to know in order to work out the problem based on the different elements. This is the introduction. This is the synopsis which you are supposed to know in the first chapter of the first PUC organic chemistry, some basic principles. Surely you need to practice the nomenclature. If you have any clarification, you can ask. Nomenclature, lots of nomenclatures are there. You should learn. I've given you the complete synopsis. If you have any specific questions, you can ask. You're writing the exams on Sunday, so I have to wish you the best for your exams. Before that, if you have any clarification, you can ask. Anybody is having any clarification? You can ask. Quickly, Dhanlakshmi, Roslyn.
Yes, sir.
If you are posting any question, if you're posting also, you can post. You can, now I can answer that. Yeah, okay. If you have any questions, you can post it to me. Any specific question, if you have, you can post it to me.
No, sir.
Yeah. No? All right. So anyways, all the best. All right. Prepare well and do well for your NEET exams. You let me know how was the paper. All right. Chemistry will be easy. Concentrate, read 2-3 times the question. When you read 2-3 times the question, you will understand and then you can answer. Don't panic. Go early, relax, and then do the exam. All the best. Bye.
Thank you, sir.